Good afternoon. Today we are going to talk about last things in chapter 8. We have 1-8, I mean, section 8. So if you know that we have what? We have, I think we stopped in the contrapositive, right? Stopped here. Yeah, 1.8. So here we are. Okay. So we have another strategy for proving. So we have direct, we have indirect, also we have solving by case. Okay, Kaka? Solving by case. Yes. No, thank you. Thank you, Kaka. Good. Now, that's much. Now we have what? We have solving by cases. For example, if I say we have n plus 1 cube n, look at this example, let me follow the example. You say what? Prove that n greater than that one, then if n is positive integer with n less than equal to 4. First of all, you need to understand the structure of the theorem. You see what? We have n integer number. So we have if n is integer number with, or means and, n less than 4, then prove that. Can you see? Because we say that one of the statement, Q will be at the first if P. You remember? So we have what? We have if n belongs to positive integer numbers and n less than or equal to 4, then show that n plus 1 cube, don't know what we have, greater than 3 to power n. You should learn about the how to understand the structure, then you know how to solve. Am I right? That's the question. So how we solve that one? How we understand? Before we are solving that one, I'm going to manipulate with the theorem. For example, if I say, instead of that one, if I say, forget about that one. If I say if n less than 4, then n plus 1 cube greater than or equal to 3n. Tell me about this statement. It's true or not? Yalla. Put your mobile away. False. If I put 1, 2 to power 3 greater than 3 to power 2, so 3 to power 1, so it's true. What was my question? What was my question? I said that one is true or not. I don't say it's a proof, it's a theorem. I say this is the statement, proposition. True, right? Am I right? Any other idea? It's false. Why? Negative 1, for example, negative 1. Right? If I have negative 1, what do you mean by negative 1? He say if n is equal to negative 1. So from the right side, my question is negative 1 less than 4? Yes. Good. So from the right, this is the left side. For the right side, if I put minus 1 plus 1 to power 3, I'm going to ask myself, that one is true or not? Am I right? I'll get what? 0 to power 3 I'm going to check. That one's good. 1 over means that 3 to power minus 1 means that 1 over 3. Is that true? No. So generally speaking, if I don't specify what's n, sorry, I cannot answer the question, or I cannot prove it, or I cannot say it's true or not. I don't say it's a theorem. Who says it's a theorem? I just general statement. Okay. So if I say n belong to Z positive, what's Z positive? For example, am I right? Understood. And n less than 4, what I mean by that? So, sorry, do not mention anything. Just if I say n belongs to the Z positive, and show me that, prove that this statement is true or not. N plus 1 over 3 to power 3. That one is also true. It's true. Really? How about 5? If I put 5, I'll get 6 to power 3. I'm going to check. Is that one true or not? Kindly, you can check. 6 to power 3 is equal to what? Do it by your mobile, kindly. Yes? (36 by 6). On the other side? Do you think that one is true? No. So if I say let n be 5, also we get false. You got it? So the condition is very important. That's why we talk about it for all that exist. But how about if I say if n belongs to Z positive and n less than or equal to 4, then n plus 1 cube. Do you think that one is true? Why is true? Tell me about n. Set of n is what? 1, 2, 3. Am I right? If I put n, case number 1, if I say let n be 1, I will get what? 2 to power 3, 3 to power 1, which is true, right? 9 is greater than 3. You got it? Not 9, sorry. 8. 2 to power 3, 8. Good. Case number 2. If I check 2, let n be 2. So 3 to power 2, I'm going to check, is it 3 to power 2 or not? Am I right? What? Sorry? 3, 3, yes, you are right. Is that one true or not? Yes. 27 greater than 9. So second, also okay. Case number 3, if n is 3, I'll get 4 to power 3, 3 to power 3. Of course, 100%. And last case, I have what? 5 to power 4, of course, greater than 3 to power 4. So all cases, one by one, because the case wasn't a lot. Listen to me, wasn't a lot. We don't have a for all. How many cases do you have? 4 cases. So I'm going to solve it by case. So we have a direct, indirect. Yeah. It's okay, the same. Of course, true. Okay, thank you. So all cases that we have, all of them, they are true. So we solve it by 4 cases. It's called solving or proving by cases. When we are going to use that cases, when we are going to use that method, when we have a little bit cases, 10, 5, 2, 3. So you don't need to take a lot of proof. Because if I am going to solve direct, I cannot prove it, right? Because you should prove it generally. But here we specify the case. We say n less than 4 and positive. So we have a boundary of steps. In that case, we are going to solve our cases. Do you have any question about it? You know where we are using that one? Hello? Good. So that's all about solving by cases or proving by cases. Here we are. Here's the example, case number 1, 2, 3. Now, another example. Look. Prove that if, where's P? N is integer. So N belong to all integer numbers. Am I right? Then show me that N square usually greater than N. So how we solve that one? Do we have any given? No. We just say N from integer. So how we solve that one? In your mind, think about it. It's okay. I know it's true. Okay. And 0 is not true. So we have equal. Okay. Good. So how you solve? Graph? No. Let me give you a clue. Solve that one by cases. How we make the cases.
This is an integer. If you add any number, minus 9, minus 10, or anything.
Okay. That's the first. Thank you. No. You make it deeper.
First, we can open 3 cases.
Like?
1 negative, 1 0, no positive.
So, because integer number can be dealt with what? Positive, negative, and 0. So, for the cases, we are going to divide this into 3 cases. We are going to deal with that one of the cases. Z greater than 1, Z less than minus 1 or equal طبعا, or Z equal to 0. Why I wrote like that? Why I didn't wrote like, for example, I say Z greater than 0, or Z less than 0, or Z equal to 0. The same. That one are the same, equivalent. This rule with that one the same, yes. How many numbers do you have in Z? Did I say one by one do it? No. We make the group. 3 cases. Just take it easy. We make 3 cases. Okay, so tell me. Okay, so how we show that one's true? Yalla, N is positive. Can I solve it by direct? Of course no. If you want to solve it, you need to follow the cases. Because there is no given. There is nothing to given. It's taken out. In the previous one, we have, you say N is equal to 2k plus 1. Do you remember? We have something work on it. In that case, yes, you are right. But here we don't have anything. We don't have an even, we don't have an odd, right? There is no given. So it just give you one clue. N is integer. Tamam. So how we solve it? Can I use it, say minus 1, minus 2? No. We all together, we make all negative as in Z less than or equal to minus 1. Or you can say Z be negative. Or you can say Z less than 0. You know? That's it. So it's not a lot, 3 cases. Okay, dears? So here we are. You can see the solution. Time to prove it. N is for every, by conclusion. So we have cases. N be 0, N be 1 and up, N be minus 1 and down, right? Decrease and increase. So we have the cases which true. For 0 is a special case. For the positive is general cases. And for negative again. It's not hard. Okay, maybe during the exam I say use by case or I don't say anything. You know, yes.
You put n part, the negative one is 1 part.
Why we change to n? Yeah, maybe, yes, of course. In that case, we have a wrong things. You're right. Understood. Good. So now you have enough time